So the circle is tangent to both the x and the y axis, which means that if we were to draw a line from the center of the circle to the y-axis, that would be one radius of the circle. If we were to draw the center to the x-axis, that would also be a radius of the circle. And we know that the length of line segment OA is equal to Q. I'm going to use a capital Q because lowercase q's look funny. I don't want them to look like a number. Okay, so we need to know what the radius of the circle is in terms of Q. One thing that to remember here is that basically we formed a square here, and you may remember that the ratio of sides of a 45, 45, 90 triangle, which this is because these are each 90 degrees and that makes each of these angles 45 degrees, is whatever the side length is, this is x, and this is x times the square root of 2. A very handy ratio to remember, have memorized on the GMAT, because it can make stuff like this way easier. If you don't remember it, you can still figure this out using the Pythagorean theorem, but totally go with the shortcut if you can. So in this particular case then, we're asked, so we can call either of these distances r. So Q, which is the hypotenuse of a 45, 45, 90 triangle, Q equals r times the square root of 2. The question isn't asking, though, what Q is. It's asking what r is in terms of Q. Of course, we can just divide both sides by the square root of 2. R equals Q divided by the square root of 2, but lo and behold, that does not appear in the answer choices. And in fact, it's fairly common when reducing fractions to not have radicals in the answer choices. So we would multiply this whole thing times the square root of 2 over the square root of 2. Something over itself is 1, right? So we're really just multiplying it by 1 and changing what this looks like. It ends up being Q times the square root of 2 over 2, because the square root of 2 times the square root of 2 is just 2. That answer is in the answer choices, and that's answer choice B.